Hey there, welcome back to the channel. Today we're going to continue work on the YoshiStat, which is a thermostat. Basically, we're going to build a smart thermostat over several weeks. Today we're going to be working on the relays, so basically the output. In order for a thermostat to turn on and off heat and or your air conditioning, it needs to close the contacts on a relay. So we're going to plumb that through. Let's go take a look at some code. If you recall, we've got this YoshiStat application, and we've got it divided into basically three projects. We've got a core project that is the common logic for all of our target platforms. Then we've got two target platforms defined. We've got the desktop and then the YoshiPi. The YoshiPi, which is our current hardware, at least for doing, prototyping, it is, let's see if we can get it here. It's this right here. And so we're going to be running on this hardware, but because it's a pain to always deploy to hardware, we're also going to do a desktop one. And so we've got a defined desktop target as well that lets us just do basically a simulation of all of this stuff right here under Windows. It actually would run under Linux desktop as well. Should run under Mac. Again, today what we're going to do is we're going to work on the relays. So when the HVAC, when your thermostat calls for heat or calls for cool, it sends 24-volt AC to the control board, usually in your HVAC unit. That's for like something with a central air handler with a condenser and maybe burners or resistive elements for heat. It would be different if you've got, resistive like baseboards or if you've got steam, those kinds of things. I'm less familiar with how they work, so I'm not positive how the control systems on those work. So your mileage might vary on whether or not this would work. But for forced air, which is what I've got here at my house, and that's what I'm going to be designing this for. Basically, when it says call for heat, call for cool, or in fact there's call for fan, it just connects and sends 24 volts. 24 volts already comes up to the thermostat, so all we need is a relay to connect those two. So we're going to drive the relays. The YoshiPi has two relays. The contacts are here. The relays themselves are down under here. It's a solid state relay. Doesn't have a whole lot of amperage capability. I think it's something like 400 milliamps per channel, but this doesn't require a whole lot of amperage. Basically, we're just connecting the two to give it a signal to turn on. So the current to drive the air conditioner or drive the fan, those things are not going through the stat. It's only the signal in order to turn those on. So this should be more than adequate to turn those on. Rather than having to push our application to hardware and test on hardware, I like to do as much development as I can on the desktop, and this is going to be no exception to that. We're going to add the capability on the desktop to do relays. The output for the relays, rather than physically turning something on and off, will just send on and off to as text to the console. And then in order to turn it on and off, we will either put some buttons on the UI display, or we could actually use keyboard to turn it on and off. Haven't quite decided exactly what we're going to do. That's what we're here today to try to figure out. So let's get started on building all of that out. The output service is really where this is going to happen. It's going to drive the displays, or drive the relays. And we can see we've got set heat and set cool. I've already got those in this interface, but I don't think I have anything that implements this interface anywhere. Nope, I do not. So we're going to create these for both the desktop and the YoshiPi. We know that they are going to be different in how they implement the interface. So we will have one in each of those projects, as opposed to like the display service, which is common across all the platforms. And so it is here in core. And in here, I'm not certain that we need relays. We might be able to just output directly to the screen that heat is called for or cool is called for. But in the event that we need to simulate the relays for some other work, we actually have a simulated relay in Meadow Foundation. So I'm going to add 2 relays, one for the heat, one for the cool. And in fact, now that I'm thinking about it, we could do simulated relays for heat and cool, and maybe even have the output service in core itself. So just as I'm thinking about it, we might end up going that route. I'm going to build this in the desktop project for now, but I'm going to use interfaces and try to make it as generic as possible. If I can make it really generic, then I can push the service into core and have the creation of these relays in the platform hardware. So let's take a look and see how that works. I think we might be able to get away with putting the output service up into core and have the relays as part of the hardware. Yeah, see, we can use simulated relays. So let's do this. Let's bring in these into the output service. So if the state is on, we're going to close the relay. Otherwise, we're going to open the relay. And it's important here that we can add some kind of, I guess, logic or some safety. We know if we're setting the cool to on that we don't want the heat on. It should never happen, right? Our application should only be driving either one or the other, but we can add some safety here and say when we turn the cool on, let's force the heat to be off. Or if we turn the heat on, we force the cool to be off. We'll just open that relay if cool is on and do the same thing down here for heat. If heat is on, then the cool relay will be open. So it's a really simple service. We just have these relays that are going to get passed in, and setting the state turns them on and off. Easy enough. So now let's go over to the desktop hardware. And in fact, let's go to the YoshiStat hardware interface. And let's add some relays here. So we've got the heat relay and the cool relay. So now if we go back to the desktop, actually not the desktop, let's go back to the main controller, and we're going to have an output service. As a refresher, the main controller here, this is where the state machine, all of the logic that ties all of our inputs, our outputs, the UI, all of that, it's kind of the routing central piece that takes signals in and out and decides which services need which information and ties it all together. This is where the logic of the actual thermostat happens. Everything else is just a service for bringing in sensor data, setting the relays, handling the display, that kind of thing. The main controller is where the actual thermostat logic itself is going to reside. So it already has a display service for the output. It has the sensor service, which is our temperature coming in, a reference to the hardware, the actual physical hardware platform we're running on, the YoshiPi or desktop. And now we're going to add the output service, which is going to need those relays. Already, we're going to need to move this output service up into the core. So let's just take it and drag it up here. Okay, so our output service is here. Let's go back to the main controller, and we're going to create an instance of this. And it needs the heat and cool relays, which we just added to the hardware interface. So we should be able to do hardware dot heat relay and hardware cool relay. Now our output service is created with those relays, but now we have to add those relays to the hardware implementations. So if we come down to the desktop, we should have an error here, which we do, because we need to add these two relays. And we'll just add getter properties on these. And so the simulated relay, it's just an implementation of that I relay. And, well, we'll take a look at how it works. But basically, it's just going to have an input. You know, it's got a Boolean variable inside to know whether it's open or closed. And I think it's got an event for when it opens and closes. So on this, what we can do is we can, we'll add some sort of an event handler to output to the console. So I create this relay and we can name them. And we'll have both of the relays go into this same handler, because really all we're going to do, the sender is going to be a relay. Okay, so the relay state comes in, and I'm pretty sure that the sender is the relay itself. Now let's add the other relay, the cool relay. So both relays, when they change, they're just going to output to the console what their new state is. All right. So now our desktop hardware is implemented, but if we compile, this is going to fail because we also need the relays here. And here our hardware is the YoshiPi hardware. And again, it has relays on board, so we can actually just do hardware dot relay 1 and hardware relay 2. That's all there is to it. We've implemented that entire interface because these relays are part of the YoshiPi interface. Okay, so let's go back to the main controller. In fact, let's just compile everything, make sure we've got it all done. Now we just need to exercise these relays. The easiest way to do that right now, in the end, it's going to be handled by the logic, you know, looking at the ambient temperature or the room temperature and turning on and off heat and cool based on the set points that you have. We don't have any of that logic plumbed through yet. So rather than worry about it, what we're going to do is I'm just going to put, say, a couple of buttons on the UI, so just on the display, that we can use for, you know, clicking to turn on and off the relays. We will then, you know, eventually get rid of those same buttons and maybe reappropriate them. Haven't gotten any design work back yet. I think Jorge's just been busy. That's fine. We've got plenty of work we can do, but we'll just throw a couple of buttons on the display, show you how that works. And then we'll use those buttons to trigger the relays, make sure they work on the desktop, make sure all of that's plumbed through, then push it down to the device and test it out on the device, make sure it's actually closing and opening those relays. So let's go over to the display service here, and we're going to add a couple of buttons. My temptation is to call it, you know, like increment or decrement or something that we know we're going to end up using eventually, rather than heat and cool. But I can rename these later. Just for clarity, we'll call them heat and cool for now. And we're going to put these right onto the home layout. If you haven't watched the video where I go through building up the display service, I can give you a recap real quick here. So the display service, the way this works is a lot like a UWP or WPF app, something like that. Maybe a Xamarin app if you're familiar. We've got layouts. So we've got The screen is the container, and it basically abstracts the physical screen that we're working on. On the device, it's that physical screen. On the desktop, it will be a root window. Inside of it, we have layouts. So we've got an absolute layout, which is a container for controls. And inside of the layout, we've got controls that we can position, and those controls do all of the rendering. So I've got this home layout. My thinking is we're going to have a layout per screen. So we'll have like home and then maybe a settings layout and I don't know, something for adjusting temperature. I don't know exactly how all that's going to work, but think of each layout is a screen in the application. And so that layout gets shown or displayed on the screen. And when that layout gets shown, all of its children controls get shown. Right now we have a current temperature label that just shows the temp coming in from our input service, which is either a temperature sensor or it is a simulated temperature sensor on the desktop. So we're just going to add a couple of buttons below that label, one for heat and one for cool. Not even going to put icons or anything else on them right now. Just going to put some text on them. You can see here, the other one has like a 5-pixel border. So we're just going to do the same. I'll go 5, 5, its width. I'm going to go with, in fact, let's just use the same as this label here. The home layout width, -10 because of that 5-pixel border on the left and right. And then its height is going to be 30. I think we don't need anything else for the button. We can scale the button to make it larger or smaller, but we're already scaling the screen. We don't need to worry about that. We'll leave that at 1. And we can set some additional properties here. Color and, you know, the down color, the up color, a bunch of things like that. Really all I want to care about right now is we'll just set the text. And I don't want it at 5.5. We want the top to be at the current label bottom +5. So we'll have the current or the temperature label, then a 5-pixel buffer, and then this button right below it. And then we can actually do the cool button. If you're familiar with any of the Microsoft technologies, like even back to WinForms or older, you know, VB6, VB5, when you build something in the designer, it always generates this long page of initialization for your controls. Really, that's what this create layouts is, this analog of. We have to manually build it because I haven't done a designer and don't have any intent to build a designer. So you have to manually create this, but you can see it's not terribly hard. All right, so we have all of that. And we'll add some handlers right now. Trying to decide if we should just, you know, test it out and make sure they show up or add the handlers. Let's add the handlers right now, and then we'll run this and make sure that everything shows up in the display like we're wanting. I'm just going to clear those out. So right now, I'll actually put a breakpoint in there to make sure that they're getting hit when we run them. But the display service, we've got that, and it's on heat and on cool clicked. Now, one of the important things of this is the display service is not going to know about the output service. It doesn't know anything about relays. So it's simply going to raise events here that the main controller will then receive, and it will then call to the output service. We're separating these concerns, right? We don't want all of the services intertwined with one another. So the display service knows absolutely nothing about the output service, and we're going to keep it that way. So when we click that button, it's going to just turn into a request for changing the state of a relay. And when that request comes in, the main controller is going to receive that, turn that into our business logic that will then proxy that call back out to the output service. That's going to require that we implement some events here in the display service. But first, before we get to that, let's just run this on the desktop and see what happens. So there's our temperature. It's a simulated temp that's just randomly walking around. And of course, it says heat and heat because I didn't change this. If I click heat, and I'm not getting click events. It's not even changing. So question is why? It's a good question. Something else is probably syncing the click, so it might actually be a bug in that button handler. I know I've used these before, so it surprises me a little bit. So how else can we test this out? Let's add handlers for, since we're working on the desktop, and see, this is one of the nice things about working on the desktop, allows us to iterate on these. Admittedly, we shouldn't have had a bug, but it's software development. What are you going to do? What I'm going to do is I'm going to use my keyboard and have the buttons on the keyboard. I'll map a couple of those to heat and cool. We could use arrows. We could use the H and C for heat and cool, whatever. So I'm going to add those in, and those are going to pipe through to the display. Trying to think of the best way to do this because we're abstracting this all the way out. This should be all the way up in the hardware. So let's add a push button on the hardware. We've got a couple of push buttons here. My intent was not necessarily to use those buttons for anything because I just wanted to use a touch screen. But let's implement one for a test button for now. I'm not sure what we're going to call it because I don't know what exactly we would use it for in production. But we'll just call it a test button, right? This gets a little confusing because we've got physical hardware buttons and then we have the button control for the user interface. And we're just going to, I'll add a couple of them, right? These might be handy for other things as we're doing development. My suspicion is we're going to need them when we implement some of the logic for heat so that we can use the buttons for up and down in order to control the simulated temperature and see what happens. So we'll use these buttons. And in fact, because I know that it's going to be trying to decide on what to map them to. I guess it really doesn't matter, right? I could use H and C for hotter and colder. I could use the up and down arrows. It really doesn't matter, but let's go implement these buttons and see how that works. So let's go to the desktop hardware, and we're going to need these buttons. It's at least somewhat interesting here on how this will work. We're going to use the keyboard. And the keyboard, we've got a driver in Meadow Foundation that turns the keys into basically I buttons so that they raise interrupts. So it will act just like the physical button there on the YoshiPi. But in order to get that, we're going to need the keyboard driver. So let's add a NuGet package. And wilderness keyboard. See if that's enough. Or Meadow keyboard. So it's the HID keyboard. So there are other keyboards as well for like the Featherwing or things like that. This one is just the HID keyboard. You can see in the description it's for 108 key PC keyboard. So we're just going to install that. Now the keyboard here works just like any of the other hardware in Meadow. So it's got a pins collection. So it feels just like if you were using the Meadow F7, if you were using the Raspberry Pi, any of those. So we have pins, and then each key has a pin. So let's say the C key, so the pin for it, and then we can create a digital interrupt port on it. And if well, we want both, right? So we'll go edge both for down and up because you need both to get a click. So I'm going to create that. Oh, it does. It takes in a pin. We don't even have to give it a port. So we can create a push button with that pin. And there we go. So we create the keyboard here. Let me scroll up so it's right in the middle. So we've defined a keyboard. We create the keyboard. And then this test button is just a push button class, and then the pin is the C on the keyboard. Let's go H and then C, heat and cool, just because the buttons on the screen, I think I did in that order. It doesn't matter what order we do, but so now when we push the H, test button 1 will raise its events. Okay, so we've got those buttons. Now we have to go back and implement that interface on the YoshiPi, right? Again, this is going to be very easy, and this is why I chose this hardware for us. We've got these two, and I can just do hardware button 1 and hardware button 2. So we've just mapped those directly to these two physical buttons. You can see they're labeled button 1 and button 2. Now let's come back to the, where do we want to put this? In the main controller maybe? Yeah, let's put it in the main controller. Let's create a new method for hooking all of the events, because we're going to need to hook events from different services. And here, this was on the hardware itself. And I'll give it a little bit better name, something I like a little bit better. And when one of these test buttons gets clicked, in fact, we've already got our output service, right? So let's just do output service, set the heat state to true on heat, and on button 2, we're going to do output service set cool state to true. And remember, what we did in that output service is if we turn, say, cool on here, it turns off the heat. So if we start up and we set the heat, that should turn the heat relay on. Then if we turn on cool, we should see the heat relay turn off and the cool relay turn on. So I'm just going to remove those. Let's just run this and see how lucky we are. See if this just runs. See if it works better than it did when I tried to use the button on the display. We won't see any change on the UI because we haven't plumbed anything through for that. But we will see an output here. So if I hit H for heat, of course, that's not working either. What the heck? Things are not going well. And it's really strange that I've hit 2 of them where the event handlers aren't working. It makes me question whether or not I've got some sort of a plumbing problem between, my PC and the Meadow desktop bits. The fact that we've got two drivers that didn't behave. And because of that, let's just build this whole solution again, make sure it builds. And I'm going to fire up the hardware and see if we get better behavior on the hardware itself. I still have not set up debugging. Yes, I plan to do it, but I have not. So let's open up a terminal, debug net 8, right? Everything is here. I'll create another one. In fact, I'm not going to SSH in. Might as well show you how I normally operate anyway. I'm going to open up WinSCP. And so here's our output. Come over here. Refresh. We have the YoshiStat here. I don't remember what state we were in there. So to start with, we're just going to copy everything over. That's not necessarily what we need to do, but just to put everything back into a state that we know. We'll push everything over to the device. And while it's doing that, we'll SSH in. Okay, so we've got everything in here. .NET app DLL. All right, so that comes up. Let's go back over to our bench. Neither the heat or the cool buttons are working here, which is a real pain in the ass. Don't understand why that is. That's the fun of doing applications. So if I push these push buttons, what do I get? If I push them, I get nothing here in the console either. So we get the same behavior on the desktop and the hardware. I just have to figure out what that the problem with that behavior is. I'm not sure why it's doing that. Okay, I'm going to bite the bullet, and I'm going to add in references. Normally, I would have done this in any normal project anyway. I was hoping we could just build all of this with NuGet packages, and once we fix these issues, we'll get these bugs pushed up to the NuGet packages. So hopefully we can revert to NuGets at some point. So let's add a bunch of things. And there are more reference projects that these refer to, which is why you can see it's much more friendly, I guess, if we use the NuGet packages. But for now, this is what we're going to do. So let's take a look at, first I want to see why the push buttons on the keyboard aren't working. I'm going to push the C. Okay, so it knows that it's there. We're going to set the state. It creates a digital state. So it creates a port result. Changed does have a handler. So it's thinking that the press duration is 1.2 seconds. That doesn't make any sense. I mean, it says the duration is 25 seconds, right? So we are losing something. Interesting. So it's inverted. It's giving us an up and then a down rather than a down and an up. I'll come over to the YoshiPi and see what it has in its samples. Press started and press ended, but I don't see that I tested clicked. Wonder if it's just a bug in click and we can do a start and end. Let's do that. Let's change the route we were going here. Let me find our app again. Instead of doing a click, so frustrating. Let's look at press started instead of the full click. So there's absolutely a bug there. We'll get that reported, hopefully get it fixed. But let's start with this. So if I hit H, hey, look at that. And it comes in here on the press started. So the click handler has a bug in it. Oh, that's frustrating. So I hit H and that closed the heat relay, right? So I hit H again. You can see it's going up and then down rather than down and then up. So there's absolutely a bug there. If I keep hitting H, it does nothing because in our controller, we're just turning heat on. But if I hit C, that should close the cool and open the heat. Right? So it opened the heat, closed the cool. Now if I hit the H again, it closes cool and opens heat. So you can see that the service, the output service, is correctly doing its thing here. Let's rebuild this for the YoshiPi. I'm just going to copy everything Meadow related across. So now we are up here. And if I push a button, hey, look at that. We get down and up. Down and up. So that's our down and up we see are working on the hardware. Now let me find a meter. So we're checking continuity. Now I should be able to look at the two relays. And when I push a button, so heat is now on and cool is off. And if I push this one, it turns this one on and this one's off. So we can see that I can push these two buttons and it is physically closing these relays, which is what we expected. All right. Wow, that was painful. So let's do a recap of what we achieved today in our... We had an I output service here. And so it has the set and heat and set cool, which we want to just turn on some relays. Basically close relays when it's on, open the relays when it's off. We implemented that as an output service in core. So in a service that is common to both desktop and the YoshiPi, and it takes in these relays, one for heat, one for cool, takes them in as an interface. Setting the state on those basically just closes or opens the appropriate relay. And as a safety measure, if we close a relay, say for heat, we open the one for cool. We force at this point that you cannot have both the heat and the cool relay closed at the same time. It's not possible with our logic. No matter what happens upstream from here, we force at this point, basically right when we're going to the relays, to make sure that they are never done at the same time. In fact, we could do some timing things here to make sure that we don't toggle them too fast. We will probably add some of that in a later video. Once we have this output service, now we need to send these relays into it. Those relays on the desktop are simulated relays, and they are implemented. Let's go over to the main controller first, where this output service comes from. So the main controller creates the output service and passes in relays which come from the hardware, which is our iYoshiStat hardware interface. So we added these two relays. We also did add a couple of test buttons. But let's keep working upstream from those relays. So the main controller gets those relays from the hardware, and the hardware on the desktop, we implemented that relay as a simulated relay, and the cool is also a simulated relay. These are in Meadow Foundation. Basically, it just wraps around a bool and gives the proper events and a name. On the device, those are simply a wrapper around the physical relays on the hardware. Because we ran into some bugs, we added a couple of buttons. These are I buttons. This not to be confused with the button on a touch screen. This is a physical hardware button. So we created these, and again on the YoshiPi, it just maps right to these buttons here. And on the desktop, we mapped that to the C and the H button, right? And in fact, let's see, the C continues to work, so we could change this back to what we had, right? Because both the C and the H were working. We've got some sort of a bug where it thinks up is down and down is up. So we also ran into that bug. So what we did here is we create that button, and then up in the main controller, we hook the button events. I tried click fails because that inversion of down and up. So we got nowhere with it, but when I change it to just a started, which is really just the initial change in direction, then these worked. So when I push this button, this handler happens, which calls to the output service, which sets the state, which changes the relay. So we did basically a full circle on hardware in the loop. And in fact, if we look at this over here, we did that full circle where a push of a physical button goes into our, I guess it doesn't go into the inputs. That should have gone into probably an input service, but this goes directly into our main controller. Our main controller then calls to the output service, which then closed these, or opened, I guess both, closed and opened relays. So we've got a full physical hardware loop here tested out. So physical inputs to physical outputs, and we mocked it up on the desktop as well. That's all I've got for you today. Thanks for watching. If you've got any questions, again, reach out on Discord. You can put it into the comments below this on YouTube, however you want to reach out. If there are any things that you would like to focus on, you'd like me to cover in more depth, feel free. Again, I stream this usually Saturday mornings, starting at 9-ish Central Time. So you are always welcome to come join the stream and ask any questions there as well. Hey there, quick update. After I had done my stream, I went back and tried to debug some of the button issues. What had happened, in fact, let's go take a look real quick. In the display service, I had not passed in a touch screen. So when we created the display screen, there was no touch screen. So basically, we were creating the display with no touch screen to begin with, so therefore we weren't able to get any kind of click events or anything like that. So it was simply a bug in the display service here. It wasn't actually a bug in anything underneath. So you can see here that these buttons actually are getting the events. And let's see, the last one I clicked was cool, so heat should be off, but cool should be on. And if I change back to heat, heat should be on, cool should be off. And again, if I just hold it here, cool, back to heat. So you can see that on the hardware here, from touch screen all the way down through is plumbed. We can use the touch screen or these. These will end up getting unhooked, but the reality is these buttons are going to be something different anyway. So you can see we've got multiple paths that are connecting to the hardware. Again, all of this code will be checked in, and I'll have a link down in the description. Thanks for watching.